Okay, Wiley, question 13. So the question is, how many signals would you expect to find in the proton NMR spectrum? Okay, right. Of the molecule CH3OCH2, CH2OCH3. Right? What's going on here? Alright, so I just kind of wrote it out in expanded form. Okay, so to answer this question, I need to know about, homotopic versus heterotopic hydrogens, and that comes from page 401 to 402 in the Solomons and Fryle textbook. So I'll just read it. So it says, how do we decide whether two or more protons in a molecule are in identical environments? One way to decide is to replace each hydrogen in turn by some other atom or group, and then use the result of the replacement to make our decision. If replacing the hydrogens by a different atom gives the same compound, the hydrogens are said to be homotopic. So these hydrogens here are homotopic because if I put a chlorine here or a chlorine here, this would become the first position in naming this molecule, and we would go across. And if I put a chlorine here, this would be the first, and we would go across. But it's symmetrical. So this is an ether, right? It's methyl, ethyl. Maybe it's like methyl, ethyl, something ether, whatever. It would have the same name. It's the same molecule. Whether I put the Cl here or the Cl here, it would be the same molecule. These are homotopic because if I put the same molecule, if I put the Cl here or the Cl here, it would be the same molecule because it's symmetrical. It wouldn't change what the molecule is. Okay, so homotopic hydrogens have identical environments and will have the same chemical shift. They are said to be chemical shift equivalent. Alright, so then if replacing hydrogens by a different atom gives different compounds, the hydrogens are said to be heterotopic. Heterotopic atoms have different chemical shifts and are not chemical shift equivalent. So if I put a Cl here, it would change the molecule. It would be a different molecule than if I put the Cl here. So these are heterotopic. So there's two sets of homotopic. These are homotopic, and then here's the second set of homotopic hydrogens. So there would be only two shifts. There would be two signals coming from there. So that's how I got that answer.